All right, friends and families, welcome back to Math Time with me, Miss X. I'm so happy to have you all here again. For today's lesson, we're going to be taking a look at word problems again. We're looking at it in depth. And the way that we're going to do that is we are going to be creating our own word problems based on a tape diagram that is given. So let's go ahead and look at that together. But before we do that, let's look at our objective first. So remember, our objectives are always broken up into 3 different parts so we know exactly how we're going to do something, what we need to understand about it, and then lastly, why we're doing it. And usually it's to see why it's important or why we need to even go through with it. Let's take a look at our objective. You can read with me or in your head as I read out loud to you. I can use a bunch of different strategies to solve for unknown addends. Remember, addends also means parts. So the addends just means parts. In order to see fact families. So that's a really big job, my friends. Don't worry about it. Don't be scared. We're going to do it together. Let's go straight into our teacher model. For our teacher model today, we are going to be looking at a word problem. So you may read with me or in your head as I read out loud to you. Nikhil's tower is 15 blocks tall. He added some more blocks to his tower. His tower is 18 blocks tall now. How many blocks did Nikhil add? Okay, my friends, so remember, great mathematicians, we always go back and we reread the problem. That's the first thing to do. The second thing we do is we look for and take note of important numbers that we see and hear about. Lastly, we underline our question so we know exactly what it is that we're being asked of or being asked to solve. Okay, let's go ahead and do that. Nikhil's tower is 15 blocks tall. Already, I see an important number, so we're going to go ahead and circle that. He added some more blocks to his tower. So I don't know, there is not a number in there, but I have some important operation clue words there, which is some more. So I'm going to go ahead and keep that in my head. His tower is 18 blocks tall now. Okay, that's the last important number I'm seeing. Let's go ahead and underline our question, which is how many blocks did Nikhil add? Okay, so now that we've finished reading it, we've underlined our numbers and, we've underlined our question and circled our important numbers. Let's think to ourselves. The numbers that they give us, does it represent the part or the whole? That's a very important thing to think about. We are not always adding. We are not always adding. So let's go back to the beginning again. Nikhil's tower is 15 blocks tall. I think that might be a part, but I'm not exactly sure yet. So let's keep going. He added some more blocks to his tower. Something about the words of added some more tells me we're missing a part. I think we're missing a part. So then 15 might be representing a part. Okay, let's read that last sentence. His tower is 18 blocks tall now. I think 18 is going to actually represent our whole. And let me tell you why, my friends. Because I'm noticing a change. So I noticed that 15 is what Nikhil's tower was originally. And then I heard in the story that he added some more blocks. I don't know how many, but I just know he added some. So there was a change in the number. And now his tower is 18 blocks tall. So that is the final result, and that's telling me that that's going to be the whole or the total. So let's go ahead and draw our tape diagram together. You may draw with me as well if you would like, and that would probably be very helpful. So let's go ahead and do that. So we know that Nikhil's tower is 15 blocks tall. So let's go ahead and draw. And remember, my friends, I like to use empty dots to show. Oh, we're going to run out of space a little bit here, but that's okay. To show 10, so to show our tens. That just makes it a little bit easier. And then, so we know 15. So we have that 10, and then we're going to draw dark colored in circles to represent our ones. Let's go ahead and box that in. And we're going to write 15. Okay. And, so I don't really know how many he added, how many more blocks he added, so we're going to put a question mark. And my friends, it's super important that we put a question mark for what we are solving for. So for example, in this problem, we are solving for the part. So we're going to put the question mark where the part is. And for 15, we're going to go ahead and we're going to mark it or label it as what he originally had. So let's go ahead, we're going to put an S for started, what he started with. And then we're going to put an M for how many more he added. So the more that he added, the amount that he added. Okay, now let's keep going. So we drew our 15 blocks, and that's what Nikhil started with. He added some more. We don't know how many more he added. That's why we're putting a question mark there. Now, we do know, though, that his tower is 18 blocks tall now. So let's go ahead and put 18 at the top to connect and show that it is our whole or our total. Okay. Now, there are many different ways we can do this, but before we do it together, I want you to pause the video here and go ahead and try this by yourself first or with a friend or family member, and then we will do it together. Okay, welcome back, my friends. Let's go ahead and use our count on strategy, or we can even use our place values to help us out. So we know that in the number 18, there is 1 10 and 8 ones. We see that we have 5 ones here. So we're going to go ahead and add 3 more ones to make that 8 ones. So let's double check it by using our count on strategy. Ready? So we know that there's 15 here because we see 1 10 group here that are represented by empty circles. And we have 5 here to represent 5 ones. So 15, 16, 17, 18. Great job, my friends. So it definitely looks like Nikhil added 3 more blocks. We found our missing part. And my friends, Miss X didn't do this, but you guys should do this. It's super important to do this. We should label our whole, whoa, my pen doesn't work. We should label our whole and our parts, so we know exactly what it is that we're keeping track of. So we know that what he started with is a part. We know that how many more he added was a part. And we know that by the end he had 18, which is his whole. And our solution is 3. Our solution is 3. Now let's go ahead and put that into a sentence. Our question reads, how many blocks did Nikhil add? Nikhil added 3 blocks. Oh, let's go ahead and make that better. We can make that better by adding a language, improving our language with the word of more. Added 3 more blocks to his tower. And my friends, so 3 is our solution. We're going to go ahead and box in 3 because 3 is our solution. And then blocks is our unit because it's the thing or the item that we were counting. Great job, my friends. So that is the first part of our teacher model. Now, I want you to go ahead and pause the video here, thinking to yourself, my friends, now that we know a problem that goes with this tape diagram. I want you to think to yourself, with a family member or by yourself, try to come up with a different story that could go with this tape diagram. My friends, I'm sure you did a fantastic job writing a bunch of word problems to match our tape diagram here. Right now, I'm going to read you mine and we can see how my story works with our tape diagram, but solves for a different part and looks closely at our fact families. Okay, and you may read with me or in your head as I read out loud to you. Sarah baked 18 sugar cookies and gave away 2 to her mom and then 1 to her grandma. How many cookies does she have for herself? Alrighty, my friends, great mathematicians, we go back and we reread the problem. We circle important numbers or note important numbers that we hear and see about. And then lastly, we underline our question. So let's go ahead and do that. Sarah baked 18 sugar cookies. Oh, that's an important number. And gave away 2 to her mom. Another important number. And then 1 to her grandma. Another important number. How many cookies does she have for herself? That's our question. So we know that we're going to be solving for or figuring out how many cookies she actually has left for herself. My tape diagram is not on my page right now, but we are going to be using the same numbers still, which is 15, 18, and 3. We are still going to be using those numbers, and we're still going to be using our tape diagram with 18 being the whole and 15 and 3 being the 2 parts. We're still going to do that, but this time I'm going to go ahead and present to you my story, and it's a little bit different from the first one about Nikhil and his blocks. So pay close attention, okay? And while I'm working through it, I want you guys to think about what's the same between this one and our first one. Even though they're different stories, I want you to think about what else is different and what else is the same, or how the number sentences are different from each other, okay? So let's go ahead and do that. You may read with me or in your head as I read out loud to you the word problem that I wrote. Sarah baked 18 sugar cookies and gave away 2 to her mom and then 1 to her grandma. How many cookies does she have for herself? Okay, my friends, so great mathematicians, we always go back and we reread the problem. We circle important numbers or we look for important numbers. And then lastly, we underline our question so we know exactly what it is that we're trying to solve for. Sarah baked 18 sugar cookies. Already that's an important number. And gave away 2 to her mom and then 1 to her grandma. 2 important numbers there. How many cookies does she have for herself? Alrighty, my friends. So it sounds like to me, she did some giving away. So when we think about giving away, that often tells us there's probably going to be subtraction. When you give away, you're reducing the amount you have. So you're giving away, that probably tells us it's probably going to be subtraction, okay? Now, if that's the case, then 2 and 1 might represent one of our parts, because in parts, we can't have 3 parts. Or in a normal number sentence, we can't have 3 parts. So the 2 and 1 are probably going to be combined. And then lastly, we have our number 18, which is the amount that Sarah baked. I think that's actually going to be our whole or our total. But let's go ahead and try it out and see what we think. Okay, so let's begin by doing our tape diagram. And we can do that. We can do our tape diagram, but we might have to work a little bit backwards. Okay, so let's go ahead and draw 18. Or let's draw 18. And we're in 2nd grade now, so we're going to use our quick 10 drawing. So I have 18. And I'm going to go ahead and, let's see. So I have 1 10, and then I know that in 18, there are 8 ones. Let's see. Alrighty, there we go. So I have 1 10 and 8 ones, and that's my total of 18. Now, I know that Sarah baked 18 sugar cookies and she gave away 2 to her mom and then 1 to her grandma. I see 2 that could represent the 2 that she gave away to her mom, and then the 1 that she gave away to her grandma. I think we're going to go ahead and box that in and label that with a 3 and then put an A for away. Great. Let's go ahead and keep going. Now I do know that she did bake 18 cookies, and obviously we had that originally drawn and represented. So we do know that she has 18. So then, and I'm going to put a P here for part, and I'm going to put a W up here for whole. So then, if she baked 18 and she gave 3 away, how many does she have left for herself? Go ahead and take a look. Let's go ahead and box it in and label it in. And we'll put an H for herself. And we'll also put a P for part, okay? Okay, so it looks like I have 1 10 and 5 1s here. I have 1 10 and 5 1s here. It looks like, to me, she's probably going to have 15 for herself to eat. So I'm going to go ahead and write that in word form and number sentence form, okay? So number sentence form is 18. Remember, we always start with the whole with the subtraction number sentence. And we're doing a subtraction number sentence because there were words that told us it's going to be subtraction. We saw words like giveaway. So 18 minus 3, and that's a part, equals, oh, and let's see. And let's not forget to put a question mark in the box that we're solving for, and also the number 15. Okay, so 18 minus 3, 18 is our whole, 3 is the amount she gave away, equals 15. And we can put a little question mark by it because that's our solution. And we're going to label it our part because it's our missing part. We're also going to box in our solution. Now we're going to write our number, not our number sentence. Now we're going to write our word sentence. Ready? So, Sarah, and we know who her is. Her is Sarah. So it's important to use the name so that we know exactly who we're talking about. Sarah has 15 sugar cookies. For herself. Okay, and we're going to box in 15 as our solution and then underline sugar cookies because that's our unit. It's the thing or item that we're counting. Okay, my friends, great job. Let's go ahead and do one more to think about the different ways that we can have a fact family, okay? So for this one, for this word problem, we had 18 minus 3. For our previous problem with Nikhil, it was 15 plus blank, or mystery number, equals 18. So I'm seeing some weird patterns here, so make sure you pay attention to that, okay? All right, let's move on. Okay, friends and families, this is going to be our last word problem, and I know you all probably wrote a lot of awesome ones. Well, I'm going to share mine with you guys since I can't really hear your guys's. So listen closely, and I want you to think about what was different in each story problem, because this is our last one, and we've had 3 together. And how our number sentences are different based on the same numbers that we're using. So keep those things in mind, okay? Alrighty, let's go. And you may read me or in your head as I read out loud to you. Julio had 15 red toy cars and Roger had 3 blue toy cars. They decided to combine their toys together. How many toy cars do they have all together? Alrighty, remember, great mathematicians, we always go back and reread that, so let's do that. We reread, and then we circle or look for important numbers, and lastly, we underline our question. Julio had 15 red toy cars. Whoops, that's an important number. And Roger had 3 blue toy cars. That's another important number. They decided to combine their toys together. There's no number information there, but the word together tells me if like you're putting things together, you're probably looking at the whole amount. So I think we're going to be adding, but let's confirm by looking at the question. How many toy cars do they have all together? Oh yeah, so they're asking us for the whole amount because Julio and Roger decided to combine their toys. So the question is asking us what the amount is altogether because they chose to put both their amounts together. Let's go ahead and do that. Okay. So let's begin with Julio. So we know that Julio had 15 red toy cars. And my friends, for our tape diagram drawings, you guys can use quick tens or you can use beads if it's helpful. I think it's easier to do the quick 10 drawings, but we can go ahead and use this just to really practice seeing our 5 groups. So I have 5 empty ones to show me a 10, and then in the number 15, because Julio has 15 red toy cars, we're going to go ahead and bubble them in and darken them to show the difference, to show the ones. So our ones are darker. Okay, so let's go ahead and box that in. And we're going to box that in, write down 15 and label it J for Julio. Okay, and then next, we know that Roger has 3 blue toy cars. So I'm gonna bubble those in dark also because we know that they're representing the ones. Okay, and then we're going to put 3 above it, and we're going to label it R for Roger. Now, my friends, there's different ways to do this or to count the total amount since that's what we're solving for. And we can do that by either counting on, or we can look at our place values, meaning we can look at the 10s and 1s that we have. So I'm going to go ahead and just use count on because I know that there's 15 here because I see that 10 and then I see the 5, so I know 15, so I'm just going to count on 15, 16, 17, 18. Oh my goodness, their total or whole amount together is 18. I'm going to go ahead and put the question mark up by the 18 and put the W for whole because I know that that's the part I was, sorry, not part. I know that that's what I was solving for. I wasn't solving for the parts. I was solving for the whole. So I'm going to label P for part just so I can also see it for myself. So Julio's amount represents a part, Roger's amount represents a part, and then 18 represents my whole. Let's write our number sentence. And that's going to be 15 plus 3. Don't forget to label. Part and part equals whole, and our whole was 18. Put a little question mark there because that's what we were solving for. Also, box in, that was your solution. Alrighty, Roger and Julio, because we know who we're talking about here in the word problem, we have to be specific. Okay, Roger and Julio have 18 toy cars all together. We're going to box in 18, that's our solution, and then we're going to underline toy cars. Even though they had different car colors, blue toy cars and red cars together are still just toy cars, even though they're different colors, so don't worry about that. Toy cars is our... Okay, my friends, now moving on, I have a few questions for you all. I want you to pause after you hear my question. What was similar in all of these problems that we did together as a team? Pause, talk to a friend or a family member. Okay, welcome back, my friends. If you were thinking that all of our problems use the same tape diagram, you thought correctly. 15 was always a part, and 3 was always a part, and 18 was always our whole through all 3 of these problems. Great. Now, what was different in each story problem? Go ahead and pause, talk to a friend or a family member about this. Alrighty, welcome back, my friends. If you were thinking a bunch of different things, let's see. If you were thinking the topic was different, you thought correctly. Yeah. So the topic was different in all of our 3 stories, Sometimes the unknown or mystery number was different, meaning the thing that we were trying to solve for, the unknown and mystery number, it was different. And sometimes my number sentence was an addition sentence, and sometimes it was a subtraction sentence. Sometimes the statement answered the question, and the question was different for each story problem. So those are really important. Okay, so those are really important things that we notice across all three of our different word problems there. And that's something I want you to keep in mind as we work through the next problem set, or as you work through the next problem set and as we move into harder math. Now, my last question to you is, how could knowing the answer to one story problem help you with a different story problem? Because we did 3 together. Talk to a friend or family member first before we talk about it together as a team. Okay, welcome back, my friends. Sometimes they can use the same number sentence, okay? Sometimes they can use the same number sentence. And even when the number sentences were different, they used a related fact, like 15 plus 3 equals 18. 15 plus 3 equals 18 can still help us with 18 minus 15 equals 3, since they use the same number bond or the same tape diagram. Our tape diagram looks a lot like a number bond, doesn't it? You would have the big circle by itself up here and then our 2 small circles to represent parts. Our tape diagram looks a lot like our number bond. So there are so many important things that we learned in today's lesson. I'm so proud of you all. I know your brains are working hard. Let's go over what I want you guys and need you guys to keep in mind as you work through the independent problem set.
Okay, my friends, as you move into independent practice, don't forget to keep these 5 things in mind. Number 1, write a word problem for each tape diagram and pay attention to what you're solving for. It should match your question. Number 2, the nouns in the boxes can be used as units if you need ideas. Number 3, mix it up. Make sure you are writing word problems that also solve for missing part and not just the missing whole. Number 4, write a number sentence. And number 5, write a word sentence. Remember to box in your solution and underline your unit. Alright, my friends, good luck. You guys are going to do wonderful. Don't forget to click the link in the description box below. It will take you to the worksheet, and don't worry about printing it if you can't. Just write down the problems on the worksheet and solve it on your own the best that you can.